So that said, the people on the panel include David Brain, who's actually a founding member of the Mars Society. He was at the founding convention here in '98 as a student, but now he is one of the investigators on the MAVEN mission, which will launch towards Mars this November. Then there is Terry Gamber, who actually was a co-worker of mine at Martin Marietta when I was there, but he was actually there way before me. He goes back to Viking at Martin and worked on every Martin Marietta and Lockheed Martin Mars mission then and ever since. And there's me. And then finally we have Tony Muscatello, who works at NASA Kennedy Space Center. David, why don't you open it up? Where do you think we should be going with the Mars exploration program?
Sure. And actually, before I answer that question, I want to give a brief anecdote, because you mentioned that I was one of the founding members of the Mars Society. But actually, although he doesn't know it, my history with Bob Zubrin goes back before that to 1991, when I was a high school student in Maryland and submitted an essay to a national essay contest for the American Astronautical Society. And I'm not telling you this to toot my own horn, because I actually lived only about 20 miles from where they held the convention. But I won that essay contest and was invited to go speak, give the first professional talk of my life. It was terrifying, and it was a really bad talk, but I got through it. The chairperson of the session that I was speaking in was Chris McKay from NASA Ames, and two of the speakers that I remember from that session so vividly were Bob Zubrin talking about a mission concept for Titan that I think is a little bit of a hybrid of the two Discovery missions that were just resurrected yesterday. It was sort of a hopper on Titan, I think.
Yeah.
So a combination of the current Comet hopper and the Titan Lake thing. And Buzz Aldrin was the other speaker. I was given a certificate at the lunch for winning this essay contest, and it was supposed to be Dan Quayle who was giving me my certificate, and he had to beg out at the last minute because of some war or something like that. And so they sent this senator from Tennessee, Al Gore, to come to the lunch and give a few comments and give me my certificate. And I'm telling you this a little bit because of the connection to Bob Zubrin and ultimately the Mars Society, but I think it illustrates for me one of the big benefits of space exploration and planetary exploration in general, and that's to excite people about scientific investigation, to get them hooked, to convince them that they want to spend the rest of their careers, the rest of their lives doing something like this, thinking big thoughts like they have heard in a session that they just gave a horrible talk in. And so I think that's one of the huge benefits of exploration of any kind, whether it's human exploration or robotic exploration. And certainly the robotic exploration of our solar system has been one of the highlights of NASA in the recent decades. And it has always gone very well, and we've always learned an incredible amount. And so I think where we go next with Mars should be motivated in robotic missions by the big science questions. Not do we want to fly a balloon on Mars because that would be cool, because we all agree that would be really cool. But what big science questions do we not have answered right now? What don't we understand? What must we understand? And for me, this leads naturally to a few kinds of missions, all of which you mentioned. I think that orbiting missions, of which I'm a part right now in the MAVEN mission, this is a Mars orbiter that you hear more about on Saturday morning, but I think orbiting missions give you a great global view of the planet. And I think rovers and landers give you a hyper-local view of the planet. And I think what's missing right now scientifically and both in the exploration space is something mesoscale, something that's in between the global view and the hyper-local view. So for me, that would be something like a balloon mission or a network mission that can tell us about how different parts of the planet communicate with each other. What's atmospheric circulation like? How is dust transported throughout the atmosphere? What are the magnetic fields of Mars like at middle scales and close scales? It'd be great to land in the middle of one of the magnetic fields and learn about that one. But that one, I think, doesn't give you enough insight about the entire planet's magnetic fields. And something that can move around from place to place on Mars over long distances is especially appealing to me.
Okay. Terry?
With, over the years, we've probably done 20 or 30 Mars proposals of all of these different concepts. And I can tell you that Mars airplanes never got a very welcome reception at headquarters because of risk for some reason. They just couldn't get with it, that they felt that it was too new of a concept, or too many problems. But Steve Squires, I think he's the one that's sort of leading the science agenda there, and Mars sample return, which I worked on for 20 years or so. I'm no longer at Lockheed Martin, but just consulting now with NSI and another company. But Mars sample return is a doable mission that could be done in the next 5 years if we wanted to. We actually started working that mission in 2003. We were going to do part of it in 2003 and part in 2005, bring the sample back. And Weiler at headquarters got a little nervous about the cost of that and canceled it. So we're always up against the cost challenges, even though we have great science rationale for these missions. Another mission that I think would be great would be Phobos mission, since we think that there's material from the surface of Mars on Phobos. If we could bring some of that back, just like the OSIRIS-REx mission is doing, that would be an interesting mission for the next robotic mission if we don't have the money for Mars sample return. I think ISRU demonstrations, like Bob's working on, would be very valuable. I mean, I think we need to tie our future missions to human exploration objectives somewhat, to, if there's some major thing we could do to enable a human mission in our next robotic mission, that would be a good thing.
Okay. I actually, is not a cop-out. I actually favor a multifaceted, varied Mars robotic exploration program, which means a lot of small and medium missions, and not focus it on a single flagship mission. I am therefore skeptical of for instance, the current plan, which attempts to focus on a Mars sample return mission, in particular one that is been made extraordinarily complex, as described as the sample return mission, and which therefore they must collect the samples in advance with a sample collecting rover. Then they must perform a precision surface rendezvous to get the samples from the rover to the ascent vehicle. And then for some reason they want to have the ascent vehicle go to Mars orbit and rendezvous with a solar electric Earth return vehicle, which then does not return to Earth, but goes to a point in interplanetary space near the Earth, where astronauts from a space station at L2 will go and get the sample from the solar electric spacecraft and bring it back to a laboratory at L2, where it can be studied free of fear of back contamination of the Earth, although they soon will have to confront the problem of back contamination of the L2 space station and need another space station to take the sample to before they bring it to L2. And this is, to me, it's the most complex sample return mission plan I've ever heard, and I've heard a few. And if you consider the fact that with Curiosity, we just demonstrated a system that can land a ton on Mars. Okay, and with a ton landed on Mars, if you make it a small sample, you could deliver to the surface a fully fueled Mars ascent vehicle capable of delivering 0.5 kilogram right back to Earth, okay, along with a small rover for it to collect its sample from the immediate vicinity. Now, if you had that as your approach, where you simply shot the sample straight back to Earth, and then it wouldn't be the sample return mission, it would be a sample return mission. Okay, because after all, there's lots of different places on Mars that are probably worthy of sampling. If you're trying to study Mars with samples, it clearly would want to try to get them from a lot of different places. And furthermore, this reduces the risk associated with one grand mission. I think I could support that. Okay, I think you could have an approach like that which does not preclude a variety of other forms of exploration. For instance, delivering more MER-scale rovers to different places on Mars, armed with different instruments. Curiosity is a very good mission, and I anticipate great things from it, but it should be recognized that for the cost of Curiosity, you could have sent 6 more MER rovers to Mars, and going to 6 places and with different instrument suites and so forth. And of course, if Curiosity's landing had failed, it would have been a total wipeout, whereas if you sent 6 and 2 failed, you still have 4. I also think aerial vehicles, and in this case, they either have to be capable of long-duration flight or repeated flight. I don't think that sending an airplane that has a 20-minute lifetime on Mars and then crashes is a worthwhile mission. In Martin, we looked at long-duration balloons called super-pressure balloons that could cruise for months. This could explore on the mesoscale. Also, if you're doing radar, if you're closer to the surface, it's a tremendous advantage. Radar signals go as the inverse 4th power of the distance in terms of strength. Or hopping vehicles that could, once again, use ground penetration radar at kilometer altitudes instead of 300-kilometer altitudes associated with orbiters. But in general, what I'd like to see a multifaceted program that could include sample returns with small samples from multiple places, along with more rovers and more of this. But I do not think that we're going in the right direction if we focus the entire robotic program on a grand sample return, as has been put forward from headquarters over the recent period.
Well, I'm tempted to say all of the above, but to focus down a little bit more than that, I'm strongly in favor of a Mars sample return mission, but not just any Mars sample return mission, but one that's propelled by in situ resource utilization generated propellants, as taking the Martian carbon dioxide and Martian water in the regolith and generating hydrogen by electrolysis of the water and converting the carbon dioxide into methane and water and then electrolyzing. So you get a methane oxygen propellant that would be sufficient in scale that you could take your sample and bring it all the way back to Earth rather than all these intermediate steps that make the thing drag on for years. And, there's a risk in making something take too long, is that the risk of cancellation grows every year. And so you need to actually make it a lot more focused. Now maybe the Mars 2020 rover can supply a cache of samples or not, but you should have at least a capability of grabbing some samples in the vicinity of your lander, rover, whatever it may be, and making those part of your sample return in addition to whatever else you might have cached on Mars, so that at least you know you get something out of it. I presume they would be putting some sort of transponder on these samples so you could find them again or follow the tracks of whatever left them there, I guess, would do as well. But the reason I say that is because, well, one, it should reduce both either the mass of land that you have to land on Mars, because you generate your propellant to get back on Mars, and therefore you don't have to haul it all the way to Mars and land it. And secondly, because of the obvious things that are just being mentioned here, that it would help pave the way for human exploration. And by demonstrating this process on Mars, which is in some ways fairly simple and straightforward, in that, you know, Mars's atmosphere is 95% carbon dioxide, actually close to 96% according to the Curiosity findings very recently. And so
That's anthropogenic CO2.
well, oh, you're talking about Martian civilization. Is that why they died out? Too much carbon.
Well, it's increased by 0.5% since Viking.
Interesting. So you lay the groundwork for human missions by demonstrating the technology, and that way the mission planners will incorporate it into their plan and not feel really nervous and say it's too high risk. And that also reminds me of something else that would be useful. Now this is, I'm not sure how to put this as an exploration mission, but one of my coworkers, Phil Metzger and others, have done calculations and experiments where they say that because of the thrust of your lander is so strong in the Martian atmosphere, there's enough pressure there to collimate the plume, that you will be digging a very deep hole and fluidizing the ground, the Martian ground underneath the vehicle as it's landing, and you're going to be landing in this hole, and part of your vehicle will get covered up, that we need landing pads on Mars. Now, he said that, Phil has said that there's independent verification of this as well by some other calculations. And so if there's some way to tie a science mission to somehow paving enough of an area on Mars for a human landing spacecraft, that would be something to throw in. Something I haven't heard much talk about except amongst our group at Kennedy Space Center. Fusing the soil or something might be some scientific result out of that. But,
We've talked about a deep impact type of mission where we drop some big weight on Mars from a high altitude as we come in and try to get a crater so that we want to see, we've only scratched the surface of Mars so far, so we want to look what's below the surface. And, you know, so that might be another way to do it.
well, that reminds me of some crazy idea, and maybe it's not so crazy idea.
Or maybe an explosive.
Yeah, well, you can make an ISRU explosive.
Right.
That you make a methane oxygen bomb, essentially, that could blow a crater many feet deep. Or if you have an air burst, maybe you could melt it or something like that, or blow away at least stuff down to bedrock so that you can have a nice hard landing pad.
What are the key questions that we really think we can resolve with the robotic program? I mean, for instance, you know, one of the things we hope to do with humans is to search for fossils. Okay, you know, microfossils, bacteria can leave macroscopic fossils, even entire reefs of stromatolites. Can we, you know, are there rovers that can be made mobile enough to actually effectively do such a search? If there's extant life on Mars, it's probably in groundwater. Is there robotic technology that can reach it? Can we really address those kinds of questions, or can you know, what can we really learn from the robotic program?
I think there's a great deal we can still learn. I actually think there's still a lot of scientific cream to be skimmed. And as evidence of this, I guess I would point to a document, the MEPAG document, the Mars Exploration Program Activity Group document. And this is a group that's comprised of the scientific community that reports to NASA, but I don't think in an official capacity. But the recommendations of this document, as it's updated every 2 years or so, are taken quite seriously by NASA research funding programs and also in the context of mission proposals. And this document is broken into 4 areas, one of which is paving the way for human exploration. Another area is establishing whether or not Mars was habitable in the past. A third area that's more in my own professional research area is understanding the present and past climate of Mars. And to be honest, I can't remember the 4th area right now, but it's very important. And so this area is broken up into these 4 areas are broken up into different sub-objectives, and within each sub-objective, science questions are identified that the community have agreed upon and are prioritized. And this document is purely scientific. There's no recommendation of strategy, rover versus balloon versus orbiter, but in many places in the document it is pointed out that this science question could be addressed by a rover, this science question could be addressed by an orbiter. So I think there are lots of big questions that are still waiting for exploration. And I don't think that any one approach is invaluable, so it is not valuable. So I think I agree with your idea of many smaller missions, that you can accomplish many objectives, each on small scale, and I like that approach. And I also don't argue with the idea that returning a single sample from Mars is a valuable thing to do. It's incredibly valuable to get a sample back from Mars. But you have to weigh both sides of the equation. Is this the only thing that you want to do? Is this worth $2.5 or more billion to get that sample back when all is said and done? And if you had to go to one place on Earth and bring back one sample to tell you about the history of planet Earth, where would you go? This has been tried before, albeit not in an exactly analogous sense. This has been tried by the Galileo mission to Jupiter, which sent a probe into Jupiter's atmosphere so that we can understand globally how Jupiter's atmosphere works. And this probe landed in a very singular hotspot in Jupiter's atmosphere, not by design or plan. They just kind of let it go and it went where it went. But we got a pretty uncharacteristic view of how Jupiter's atmosphere works globally in some regards. In other regards, great science was returned. And so this is, I guess, my concern about the sample return mission or a sample return mission. I don't question that it's valuable to get one back, but I would much rather have many.
Yeah, are there questions or comments from the audience? Over Kai in the front.
I think given the political environment the last 40 years, if this continues, we can wait a long time for NASA to actually have a human mission to Mars. So I think the best hope is to hope that entrepreneurs like Elon Musk or Jeff Bezos or Paul Allen or somebody of their ilk alone in a consortium will be the first ones to send a mission to Mars. To make that easier and happen sooner, I think NASA should perform missions that retire some of the technological engineering risk that the human mission to Mars that we all want will face. One example would be send a Sabatier reactor to Mars, have it make fuel, have it fuel a rover. The rover can drive around for a few hundred miles and do good science, but we will have checked off a couple of important boxes that need to be checked off before we can successfully have humans perform missions on Mars.
Okay, that's worthwhile point of view. Have NASA retire the risks so that human exploration can be launched privately.
Can I just augment quickly? I mean, you said that private enterprise may pave the way for human exploration of Mars, and I don't disagree with that point, but I think another area which may spur things along even outside of private enterprise is international competition as well. I mean, there are other space agencies in other parts of the world that are incredibly interested in expanding beyond Earth and Moon.
Okay, others. How about right here?
Well, I think that any robotic mission should be a stepping stone towards Mars Direct. And Mars Direct, like consciousness or the anthropic principle, that has an easy part and a hard part. To me, the easy part of Mars Direct is the engineering. I have tremendous confidence that the engineers will make this happen. The hard part is the political will. So I'd like to suggest that robotic missions in the near term should be designed to do whatever's necessary to create social buzz and some excitement with some inertia amongst the people of this country. So it's always nice to do science, but science doesn't convince the vast majority of people that it would be a great thing to send a manned mission to Mars. And I'd like to know the panel's views on what we could find on Mars that could create some excitement about the future of Mars. For example, I'm pretty sure we could find where there's a large chunk of water ice on Mars, and I'm pretty sure we could send a robotic mission to prove that it's there, and that might create some social buzz about what we could do now, knowing that there for sure is a large quantity of ice on Mars.
Or a cave would be nice.
Well, actually, I think we first saw ice on Mars in the 1600s. You can see ice on Mars with a good amateur telescope during opposition. And the Phoenix mission certainly saw water ice on Mars. But, I mean, look, I think it's quite clear that as far as the public is concerned, and by the way, I think the public is right on this issue, that the relevant scientific question on Mars is there or was there life on Mars? Okay, that, you know, there are other questions that are of interest to science and planetary science in general, but certainly the central question that the world is wondering about is that. It's not the age of Mars or the, you know, so forth, or, you know, the how large is the metal core compared to the crust. And I mean, although some of these sorts of things do help lead us to answers on the central question. I'm just, it seems to me to be possible that you could have rovers that could find fossils on Mars. I find it much harder to believe that you could have robotic craft that could drill into Mars and bring up water from the deep subsurface and examine it to determine if there's extant life in it or characterize such life if it's there. That seems to me just way out there. But, you know, back in 1990 when I posed Mars Direct, people said, well, shouldn't we have more robotic missions before we send humans to Mars? Well, yeah, and we have, okay? And one of them, probably the most valuable as far as facilitating human exploration, is MRO, the reconnaissance orbiter, because now we've got the whole place imaged and we know where the rocks are and where they aren't, and this, you can land here and not land there and all that, okay? And you could plan exploration sorties and what have you. But I do think, though, that the thing that, there's basically two things that excite the public about Mars. One is, was there life? And the other is, will there be life? Okay, in other words, the question of resolving the question of the prevalence and diversity of life in the universe, number one, and number two, resolving the question of whether we have a human future as a spacefaring species. Okay, and I think in as much as if we have rovers and other robotic craft that are searching for life or searching for proof of past life or things of this sort, I think that this is something that the public will be keen on, that they will follow the program, that they will support the program, that they will insist that the program continue to be funded, and that also makes it clear why we need to know more and follow up these rovers with people.
I have one quick comment about drilling on Mars. The InSight mission discussion this morning, they're using this mole probe that inches its way down into the soil. And I don't know how it would do against bedrock, but that would be a way, even for a human mission, to extend the capability of the drilling without having to bring some very large drilling platform, that you could have an instrumented probe that could travel many meters down into the soil and be a much easier way to drill into depth on Mars to look for water and extant life or signs of past life.
Yeah, I want to make a comment too that's only half formed in my brain right now. And I guess this panel is about robotic exploration of Mars, and robotic exploration of Mars is funded by the Planetary Science Division of NASA, not the Human Exploration Division of NASA. And I think that paving the way for human exploration is a perfectly appropriate thing to do with our robotic spacecraft to Mars, but I don't agree with the idea that humans are not excited by scientific exploration of the solar system and of the universe, and that our sole reason for going to Mars is for human exploration. I agree wholeheartedly that everyone can get on board with this goal, and that the idea of understanding where we came from is a fundamentally important and driving question in almost everyone's life. But I think we have a spacecraft orbiting Mercury right now that captures people's imagination. We have spacecraft at Venus, we have spacecraft at Saturn, we've sent spacecraft to Jupiter, we have a spacecraft that's left our solar system. None of these have much to do with human exploration, although they all have something to do with human exploration. So I think that there's a chance to coexist, that you're not competing. Science is not competing with human exploration, and if there is a competition, science has already lost. Just look at the budgets, for these two types of investigations. And so it's perfectly fine to pave the way for human exploration, but there's so many fundamental science questions that teach us about how planets form, how planets evolve. Mars is not the end-all and be-all of planetary exploration. Mars is a laboratory that tells us how planets everywhere, even outside of our own solar system, have formed and developed. It's incredibly valuable, and I wouldn't sell short the science.
Okay. Claire?
Okay, certainly, possibly the most important and certainly one of the most interesting questions is there, was there, or could we create life on Mars? However, there's a little cynical part of me that says, if we find that there was, someone will say, well, maybe there still is, and a whole bunch of people, I hope not a majority, will say, we must leave Mars to the Martians. We must not put human beings on Mars. So I want to know whether you all think that's likely.
I'm going to pretend to drink my water now.
Okay. Well, I think it's certain that there will be some people that say that. But I don't think that that is what the majority of people will say. Okay, I think that if we find evidence of past life on Mars, people are going to want to know more. I think we got to go find out about this. This is interesting. This is interesting. I must say, by the way, in that connection, however, I attended a NASA workshop, I don't know, I guess it was back in the spring or so. I can't remember exactly. It was in LPI. And there were NASA people there attempting to justify the sample return mission by saying we need to know that there is no life at a certain place on Mars before we send people there. So in other words, we will, if we can assure ourselves that Mars, or at least some place on Mars, is sterile, then we can send people there. But if we discover that there's life there, then we would not want to send. Now, this seems to me to be totally absurd, since the richest science treasure trove on Mars is the question of life. And if, certainly if we found that there was biological possibilities at a site on Mars, that's exactly where we'd want to send the people, okay? And to be afraid of life, I mean, really, if you're afraid of life, you want to get off the Earth real fast. Because there's tons of it here, okay? And also, by the way, I just have to, you got me started here, Claire. Back contamination. Okay, every time you overturn a shovelful of dirt on Earth, you are bringing back a sample from the Earth of the past. And the Earth of the past was rich with pathogens. They had the Black Death here, okay, and many other epidemics, and so forth. And there's any number of life forms on Earth, including people, but also mammals, that are much more likely to be hosts for pathogens and create viable possibilities for pathogens than anything that does or could possibly exist on Mars. So really, the threat of back contamination comes from gardeners. Okay, and I must say that the obsession with this issue has been a major impairment on the NASA program. In other words, for example, the simplest Mars sample return is land a 1-ton ascent vehicle, 2 stages, small capsule, land it on Mars, put the sample in the capsule, shoot it back to Earth, do a direct entry, you know, have it come down a chute, beep, GPS is going beep, beep, here I am, you send a seaplane over, pick it up. Okay, that's all there is to it. And I mean, there's a lot to that, but it's much simpler than the other mission plan that I described earlier. Okay, but instead people say, oh no, we can't come back directly. We must break the chain of contact with the surface. So we must do an autonomous Mars rendezvous and dock. And now they're not even willing to send that back to Earth, but they want to send it someplace else and someplace.
Or sterilize the sample.
Yeah, or right, people even talking about sterilizing the sample. When, I mean, really, the most interesting science there could possibly be in that sample would be life. Okay, it's unlikely we're going to find life, even dormant life, or in a sample picked up from the surface of Mars or the very near surface of Mars. But still, if it was there, that is the most exciting thing, to say you would sterilize that. Anyway, I do think the public has its mind around this much more clearly than the NASA bureaucracy does. I think the public would strongly oppose sterilizing a sample brought back from Mars. I mean, it's essentially a crime against science. It's, you know, burn the Mona Lisa because it might have germs on it. I mean, but anyway, my answer is yes, there would be alarmists, and there might even be bureaucrats. There would be a faction at NASA headquarters that would rise to the occasion and say the sorts of things that you suggested. But I think the public in general would say, if we find life on Mars, that makes Mars worth going to. And I do think also this. I follow the space program fairly closely, and perhaps not this part of the space program as closely as some other people on this panel. But I can name every probe we've sent to Mars. I cannot name every probe we've sent to Mercury. Okay, and I think that the number of people in the public who know about the different probes to the different planets, you know, to whatever extent they know much more about the ones that went to Mars than to the other planets. And it's because this question pertains to Mars, the question of life, which doesn't pertain on Mercury, for example. Are there others? How about in the black shirt at the end here?
You almost made it.
Dr. Bryan, as you said, right now our robotic missions are going all over in kind of a scattershot profile to get what you said, like the cream of scientific study. Hypothetically speaking, if that weren't the case, if NASA's entire robotic mission had the single purpose of going to Mars and finding either evidence of life or current life, what would that program look like? Thank you.
There'd be a lot more missions to Mars, for one. So yeah, the question was if we abandoned robotic exploration of other planets in the solar system in favor of solely searching for evidence of extinct or extant life on Mars, what would that program look like? I think it would be, if I understand the sense of your question correctly, I think it would involve multiple landings at many different locations. The scientific community, for one, had a very difficult time deciding where to send the Curiosity rover. There were many different proposals, and there were 4 incredibly strong finalists. So I think you'd see missions sent to the surface of Mars in several different locations, and I think you'd see sample return from multiple locations with money that's not being spent at other planets. And although it may make me unpopular in this room or on this panel, I don't think that's a wise decision at all. Even if our goal is to understand whether life evolved anywhere else other than Earth, I don't think that it's a done deal that Mars is the best place in the solar system to be looking for life today. It's one of the best places, but may not be the best place. So I think we've proved to ourselves time and time again that if we don't get too bogged down in bureaucracy, that a balanced approach is often the best approach.
I'd like to follow up a little bit on that. Ever since the Mars meteorite, it seems as though finding life on Mars, or at least past life on Mars, has been a major, if not the major, theme of Mars exploration. Because first it was follow the water. Well, we found the water. We know it's been there. We know it has been there in the past. We know roughly where it is now, even if it's not obvious on the surface from the orbiting missions that have found high concentrations of hydrogen even on the equator. Well, obviously that's water, and it's probably bound, but it's still water. And so the Curiosity mission has examined the soil and found that, at least in this area, and probably many areas on Mars, there was a habitable environment. The pH was not too high or too low, not too much acid, and even though the perchlorate seems to be there, there are some things on Earth that thrive on perchlorate. So we've got the water, we've got habitability. The next step is, looking for either fossils or some other form of proof of life on Mars or current life on Mars.
With the blue shirt.
Isn't it awful hard not to sterilize the outside of the capsule? And you just don't open it until you put it in a place where any indication, we're similar to treating it, similar to we would some of the dangerous diseases that we control, until we can understand what's in it. Well, you don't open it until you can.
Well, there's a good.
Isn't the capsule sterilized?
Well, it can be sterilized by heat. It's certainly a lot of ultraviolet in space that we would consider more than suitable for sterilization in any hospital. The people sometimes say, well, what if it crashed and broke open? Actually, when I was at Martin, we proposed, not with unanimous support in my group, but some people liked it, a system of a capsule which was totally passive on entry. It was made of balsa wood and styrofoam, and it had such a low terminal velocity it didn't need a chute, so there wasn't a question of the chute not opening, and it was actually simpler and lighter, and it couldn't have broken open the way another capsule designed by somebody in my group did. But look, there are rocks coming to Earth from Mars all the time, and I believe about 500 kilograms a year. And according to the analysis done by Professor Kirschvink at UCLA, there were large parts, for instance, of the Allen Hills meteorite that never was raised above 40 C in its interior during its entire career in ejection from Mars, transit, and landing on Earth. And so if there had been microbes in that rock, they would have survived the trip. And in millions and billions of other rocks that have made the trip. So the idea of that we have to sterilize the sample that we bring back from Mars is like the Customs Department putting a check on anybody importing Canada geese across the border. Okay, for fear, because they're coming, you see. But anyway, but yeah, I do think the problem is greatly overdrawn, and to the extent that it greatly impaired the possibility of doing the mission. Okay, we're going to need to wind up soon, but we'll take, let's take 3 quick questions with 3 quick answers. So, in the orange shirt.
In Buzz Aldrin's recent book, Mission to Mars, he talks about telerobotics. And I know Mars Direct is Mars Direct because you go directly to Mars and don't build your base via telerobotics on Phobos. So I was wondering what the opposition is, or why directly instead of telerobotics for building bases or scouting or scientific endeavors. Like what your opinions are on it.
It's not going to be a quick answer, but there's a lot of things you could do before you go to Mars, and if you try to do all of them, you never get to Mars. And one of them is going to Phobos and using robots to build bases on Mars before you land on Mars. That seems excessive. I mean, there's some merit in a Phobos mission as such, but it's not Mars. Teleoperating robots from the vicinity of Mars is possible, but I have to tell you, we, at the Flashline Station in the Arctic, we had some telerobots we got from DARPA, which, of course, we could operate without any time delay, and these were very capable telerobots, but we tried to use them to do exploration tasks and basically competed them against what people could do. And what we found is that a person was about 1,000 times more effective than a telerobot operated by a person. That is, an actual geologist on the ground is incomparable to a robot, even one without time delay. Now, of course, if all you have is robots, then they're much better than nothing. And the MER mission is great. Curiosity mission is going to be great. I think we should have more of these things until such time as we have people on Mars. But once we can get people to the vicinity of Mars, we should put people on Mars.
So are you saying that sending people to Mars is the best way to get science done on Mars?
Yeah. But until we send people, robots are the best way to get people. Okay. In the back, with the flat hat. No, or maybe the flat hat didn't have his hand up. So then it's Cliff. All right.
It is live now, all right. So we've had about 15 successful robotic Mars missions, another handful in the works, as contrasted to 2 robotic missions to Mercury, 1 to Uranus, 1 to Neptune. I would submit that if your objective is purely scientific, then you should shut down the Mars robotic program completely and go to some other places and visit them in more detail. If, on the other hand, your objective ultimately is to put people on Mars, again, you should shut down the robotic Mars program completely and put that money into things like research on life support systems that would get people there. We have as much knowledge from the Mars probes many times over as what we had to characterize the moon before Apollo astronauts went to the moon. So what are we doing continuing to iterate this? There is maybe one robotic mission left to do that makes any sense, and that is an ISRU demonstration mission combined with a sample return. Other than that, let's shut the thing down and let's put people on Mars.
Anyone want to answer that?
It wasn't a question.
Okay. Well, it was a
Please
clearly,
put it in the
it was,
form of a
no, it
question.
doesn't have to be. It's a clearly stated opinion, and it's consistent.
No, I'm not saying that it was bad. I was just
Yeah.
saying it wasn't a question.
All right, so let's take one more with the pink shirt right here.
I've listened with interest to your somewhat skeptical comments about the mission, or the Mars return sample mission. I listened with interest this morning to the InSight experiment for seismology testing and the instrumentation that was being designed for that. And I saw, as an engineer in 30 years in the aerospace industry, a lot of shortcomings in that design. One of the things I'm wondering, and is my question to you, with all of these skeptics that we have, why isn't there a clearinghouse or some kind of oversight on the planning and the designs before implementation on a lot of these experiments? I mean, as an engineer in the aerospace industry, we had to do a requirements review of a plan before it ever went any further. We had to do and it was always done with independent objectives. We also had to do a design review, critical design review, before it went into production. It doesn't appear to me that any of that is happening on these missions, other than inside of NASA. And I don't view that as a very objective scrutiny for doing critical reviews.
Well,
Do you have any insight
I
to
have
that?
to disagree. They got lots of reviews. NASA is a review-rich environment.
No, you were saying for missions outside of NASA's purview, right? Yes. Okay, yeah, for example, on MAVEN, we've had over 200 reviews for our mission so far. So reviews only happen on days of the week that end in the word day for MAVEN. Yeah.
Okay, we're going to have to wrap it up there. Thank you very much. We're now going to have another panel, which is going to be a discussion or a debate of the asteroid retrieval mission. Thanks.